Today we're going to talk about the triangle proportionality theorem, which is when you have a parallel line coming through your triangle, what it does is it creates a small triangle to the actual bigger triangle where you have these similar figures going on. So you have like A, E, F, and this triangle is going to be similar to A, B, C. And you can do it by angle, all of those types of things, because they both have angle A in them. And then if you look at your F shape, you could have angle E congruent to angle B because of corresponding angles. So you could do it by angle, and prove that they are similar, and then push yourself to use the proportions. And the proportions being that this piece over that piece equals this piece over that piece. And that's what's shown here, AE over EB and AF over FC. So then let's get into some of the practice with this. So once again, we can put that to use. So we could say this triangle, this bottom triangle, and then the big triangle, those are similar figures. So when we look at this, we're going to do NQ to QM. So I'm going this piece and then this piece. So go up one side and then go up the other. NP over PL. So once again, start here and go to that piece. Try not to flip-flop. If I have this small piece MQ on the bottom, I better have PL on the bottom as well, making sure that those are there. Then we could substitute our values in. Let me change colors real quick. I'm going to put a little n here so that when I do NQ, I'm going to do substitution and put 5 here, and then 2 equals NP, which is the number I'm looking for, over 3. So once I get that, then I can cross multiply these and set them equal to each other. So if I times 2 on both sides, times 3 on both sides, I'm going to end up with 3 times 5 equals 2 times n, which is 15, and 2n. Divide by 2, and n is going to equal 7.5. So then I found that this piece right here is 7.5. Now, pause the video, try it yourself, but this is the value we're looking for right here. But set up your proportion. All right, so we're going to go AY. So start with the first piece right here, and then do the second piece, YC, equals AX over XB. Substitute your values in now. So we're going to put AY is 10. YC is the number we're looking for. AX is 9. And then XB is 4. Plug those in. Now it's time to cross multiply. And when we cross multiply, set them equal to each other. So I'm going to do 10 times 4, 9 times n, so that I get 40 equals 9n. Let's divide by 9 on both sides. And n is going to be 40 over 9, and can't simplify that any other way. So leave it as 40 over 9, or you could do 3 point whatever, probably like 3.4, 3.5 around there. No, not 3.5, but close to around there. Yeah, 3.5. Okay. Sorry, just trying to get that out of the way so I can tap the bottom. All right, next. If we can prove our proportion, so now we're going to prove that this side, the fraction I get, is equal to this side, the fraction that I get, then they're parallel. So the converse is always taking the flip-flop. So you're always going to do kind of the opposite. So before we knew they were parallel, so that told us that we could write a proportion. Now if we write the proportion, then we can prove that they're parallel. And when we do this, and you have the AE over EB equals AF over FC, what we can show is, or if we can show this, and what we're going to try and do is take AE times it by FC, and if that is equal to EB times by AF, then we know they are parallel. EF is parallel to BC. All right. So then let's try that. And let's use these two problems. So the first one I'm going to do is I'm going to do JM to MK. I hate when that happens. Okay. To MK. And then I'm going to, come on, JN. It might be time to switch to tip. NL. All right, I'm going to try that real quick. Sorry for the delay, but let's see if that helps. All right, maybe that was my issue. Okay, so JN and then N to L. And once again, we're going to set them equal to each other, cross multiply. Maybe it's not the tip. Oh, interesting. I don't even work with. Okay. So we're going to do JM times NL and set it equal to MK times JN. So JM 42 times NL 15, MK 21 times JN 30. And let's do Desmos, grabbing calculator, and we're gonna do 42 times 15. 42 times 15 gets 630. So this right here is 630. And is it equal to 21 times 30? 21 times 30. 630. So they are equal to each other. So that means that KL is parallel to MN. So these two lines right here, highlight them. These two lines are parallel to each other. That's what we're going for. That's what we're trying to figure out every time. All right, now we're going to see if AB is parallel to DE. Now, here's a little trick. They said A to C right here is 36. So if that's the case, and they tell us that A to C is 36, well, 16 plus 20 is 36. And then the same thing here. They told us BC, the whole thing, is 27. So that must make that 12 in order for this to be 27. 12 and 15, 27. So set up your proportion. This time I'm going to try just numbers. So we're going to do 20 over 16 equals 15 over 12. Cross multiply, we're going to do 20 times 12 and see if it equals 16 times 15. If it's equal, they're parallel. If it's not, it's not. So 20 times 12 and then 16 times 15. 16 times 15. They're both equal to 240. So 240 equals 240. Go back to our highlight, and AB is going to be parallel to. There we go. So if FE is 5, find the measure of BF. Oh, FC, I'm sorry. It's like, we have not done that yet. So this is 5. We could find the distance of this whole thing. We know that this is a jump of 1, 2, 3, 4, 5, 6. And this is a jump of 1, 2, 3. So we're going to do 6 over 3 equals 5 over u. Cross multiply, and we get 6u equals 15. Divide by 6. And u should equal, divide by 6. Is 2.5. So that means that this right here is 2.5. So we would want to create, so find the measure of BF. That's the measure of BF, 2.5. Now, you could find this Y value. It's obviously, if this is 2, you could set up that proportion and find that, but that's not what we're really doing. But it should be 8. All right, another one, kind of tricky, but still set up the same thing. This was 4x over 40 equals 5x plus 1 over 45. This one was tough on the quiz. We struggled with doing the distributive property, so this is a perfect problem to have. So when you have the distributive property, what we're doing is we're taking this number outside and we're going to multiply it by both of the things inside on both sides. So when we have this, we're going to do 45 times 4. 45 times 4 is 180. So this is going to be 180x plus 180, because it's still not going to change. 45 times 4x is 180x. 45 times 4 is just 180. Then 40 times 5, that should be 200x. And then 4 times 1, that's just going to be your plain old 40. And then you can solve that out. So we can subtract 40 on both sides, subtract 180x on both sides, solve it out. But give that a shot. Okay, last one. Tricky problem. Work through it. Don't stress too much, but set up your relationships. So we know, start with this over that. So if we're looking for AJ, we're going to do 2.5 over 2.25 equals n over 1.8. Solve that out. Once you do that, we can add these together. So for C, we're going to do Yeah, so we want 4.75 over, we'll call this x, equals n plus 1.8 over 1.2. And we know n because we solved it here. Then keep moving down your line and keep doing that, all right? Perimeter, add all the outsides together. You've got Pythagorean theorem problem here, a squared plus b squared equals c squared. Finding the area, that's 1/2 the base times the height. 1/2 the base times the height. And if a sale costs 30 per square yard, so that's taking the 30 times it by your area. Could you afford it if you had $1,000? So it's a great problem. Work through it, see what you can do, and great job.